Now I need to think about my reactants. I have 2 grams of ammonia, 2 grams of oxygen. How much nitrogen monoxide and water can I make? I'm sorry, for this one, we're using nitrogen monoxide. We're going to kind of ignore the water here. We're just going to worry about nitrogen monoxide. So first step, we need to determine how much NO can be produced from each of the reactants. So we basically do 2 problems. One problem when we're starting with the ammonia, one problem for our oxygen. All right, first up, 2 grams of ammonia. Here is my molar mass. Right, if I went back to my mole chart, it says to go from mass to moles, I use the molar mass. Nitrogen weighs 14, 3 hydrogens each weigh 1 for a total of 17 grams. So my grams of NH3 cancel out. Next conversion factor comes from my balanced reaction or balanced equation. 4 moles of NO for every 4 moles of NH3. Since I have moles of NH3, I know moles of NH3 go on the bottom. I'm trying to get to grams of NO, so my moles of NO need to go on top. I know it's 4 over 4. Still show units canceling out. Next, to go to grams of NO, I need the molar mass again. Instead of the molar mass of ammonia, now I'm using the molar mass of NO. My moles cancel out. So now I could do 2 divided by 17 times 4 divided by 4 times 30. Theoretically, if all of my ammonia was converted into NO, I can make 3.53 grams of NO. Let's look at the same thing with our oxygen. 4 grams of oxygen times 1 mole per 32 grams. Again, molar mass of oxygen is 32. Now for my balanced equation, I have 4 moles of NO for every 5 moles of O2. So my moles of O2 cancel out, and I have moles of NO. And now I can use the same conversion factor to get my grams of NO. So which one will limit us? In this case, of course, it's going to be oxygen because we could only produce 3 grams of NO. If we had more oxygen and the same amount of nitrogen, same amount of ammonia, we could produce 3.53 grams of NO. So for us, our limiting reactant is oxygen, and our theoretical yield of NO is 3.00 grams of NO. All right, so again, the theoretical yield we said was 3 grams. We used up all the oxygen. All the oxygen was theoretically used up. How much ammonia will be left over? How much ammonia was used to make 3 grams of nitrogen? So again here, we need to start with our theoretical yield. Really, really important. A lot of people start with the wrong number here, and they're surprised when they get the wrong answer. So we start with our 3 grams of NO, and we work backwards to get our grams of NH3 that were actually used. Right? Convert our grams of NO into moles. Convert our moles of NO into moles of NH3. Convert our moles of NH3 to grams of NH3. So to make 3 grams of NO, that's our theoretical yield, we would need to use 1.7 grams of ammonia. All of our oxygen is used up. We have none of that left. So now we got to think about how much did we start with? 2 grams. We used up 1.7 grams. Subtract those 2. We get 0.3 grams of NH3 left over. That's as hard as the problems get, is how much is left over. Last topic, percent yield, very, very simple. No chemical reaction goes to completion. There's always some products left over. There might be some side reactions that occur. Because if you think about it, like we've all driven behind a school bus or stood behind a school bus that was running. Theoretically, the only thing that should be produced coming out of the exhaust is carbon dioxide and water. Carbon dioxide, colorless, odorless. Water, obviously, in the form of water vapor. Again, colorless and odorless. Obviously, that does not happen. So here, percent yield is Well, how much was actually produced compared to the theoretical yield, which we've been, that's what we've been calculating, compared to an actual yield. So the formula is percent yield is the actual yield, which you need to be given. You have to be told what the actual yield was. The theoretical yield, that is what you calculate. That's what we did in the last couple examples. And times 100 to turn it into a percent. So in the last example, we calculated the theoretical yield to be 3 grams of nitrogen monoxide. If the actual yield is 2.5 grams of NO, what is the percent yield? All we do is 2.5. That's our actual yield over our theoretical times 100, 83.3%. If you ever get over 100% yield, you did something magical, and you know you did something wrong. You need to go back and fix that, because we will never get over 100% yield. If we did, that would be unbelievable. You might feel a little bit overwhelmed. We did go through a lot of material. Again, if you have any questions, you can email me at jkayer@trumbullps.org. If not, I will see you at the end of August. Good luck, and I'll put up some practice examples and the answers to go with them. Have a good rest of the summer.